routine, welfare, priority, immediate, emergency, flash. What do these mean? In Radio KD8TTE today, we're going to look at message precedence. All radio operators working in emergency and disaster communications need to understand precedence and how to use it. So, why? How do we use it? How does it work in amateur procedure? How does it work in government procedure? How does it work in Winlink? We'll address all of these questions today in Radio KD8TTE Episode 40. Stick around.
Black Swan, Black Swan.
Precedence shows the relative order in which the messages are to be processed. We've all heard Aries and Skywarn nets going. They send stuff in just as it comes, right? So why don't we just do that? If you listen closely, you'll notice that they don't always send messages in the order that they come. Sometimes you'll hear a net control operator saying something like net hold or telling stations not to call unless they have emergency or spot a tornado or something along those lines. You might hear stations then call in with keywords like medical or tornado or emergency. These are all examples of radio operators using message precedence, sometimes doing so implicitly as part of the message format. Communicating successfully, especially under adverse conditions, requires planning. If you just wing it and succeed, you're probably operating inefficiently, which limits how much you can get done working in a low-volume circuit and being lucky. Severe weather is common for emergency and auxiliary communication operations in Ohio. Looking at the National Weather Service alerts can be instructive to understand the need for precedence. If we focus on Ohio for May 28, 2021, in hour 15 of the day, which is to say 3 in the afternoon, we'll see 15 alerts being issued and what happens when we try to handle that load without precedence. This is not a simulation, we're using real data. We can illustrate this issue by making a timeline that shows 1523 through 1638. The middle row will show the minute. The top row will show within that minute how many NWS alerts were issued for Ohio. The bottom row will show any time a transmission is being made. It will show the time of the alert being sent and which alert it is. For example, if we have the first message issued at 1532 being sent, it will show 1532 followed by a 1 in square brackets. Starting at 1523, we can see that NWS issued an alert. We now have 1 in the queue for that transmission, and the transmission has begun. For the sake of this illustration, we show a period of 5 minutes between the time that the radio operator gets the alert, originates it, makes the call to the right station, transmits the message, and hears acknowledgement of the receipt. Thus, by 1528, the transmission is finished, the queue is empty, and there's nothing to transmit. At 1532, NWS issued another alert. The process then repeats, and at 1537, the queue is empty, and again, there's nothing to transmit. Hey, this is easy, right? At 1539, NWS issued another alert. The message is originated, and the transmission can then begin. At 1542, NWS issued another alert. The transmission from 1539's message is still running, so the radio operator originates a message and prepares for transmission, so there are now 2 messages in the queue, including the one that is still transmitting. At 1544, we finish the transmission of the 1539 message, so we can start transmission of the 1542 message, the only one in the queue. But NWS just issued 2 more alerts, which means we've had to originate 2 more, so we now have 3 in the queue. At 1545, we're still sending the 1542 message, and NWS issues another alert. Preparing that for transmission, we now have 4 messages in the queue. At 1549, we've finished the 1542 message, and we can start sending the first of the 1544 messages. The process repeats as NWS continues to issue alerts and we originate and transmit messages just as fast as we can. By 1555, we have finished 5 messages and have 8 messages in the queue, including the one we're sending from 1544. By the time we finish that transmission, 15 minutes will have elapsed since the alert was issued. We continue working the queue even though NWS isn't issuing alerts as quickly as they were. Those messages in our queue just keep getting older. By the time we get to our 1555 message, it's 1629 and it won't finish until 1634, giving an elapsed time of 39 minutes before the queue starts to go back down again. Even so, our 1607 message will finish transmitting 31 minutes after origination. At 1639, we're finally caught up and have nothing to transmit. Some viewers might complain that 5 minutes is an unrealistically long time. I'll deal with that in a minute, but if we reduce the transmission time from 5 minutes to 3 minutes, we can see that the same principle still applies. Alerts get issued at the time and pace that the mission requires, and the radio operators need to originate and to relay messages at whatever speed they can. Faster transmission time means the queue just doesn't get as deep and the latency is not as great. But even in this scenario, our 1555 message doesn't clear until 17 minutes later, and we're all caught up at 1615. If you were one of those that thought 5 minutes was too long, now is the time to ask yourself how long it takes you to send a meaningfully detailed tornado warning to a specific station. You need to organize the information that has been presented to you, call the station, and then transmit at a speed that they can do something with it. If Never Heard of It County has old Earl taking those messages on a legal pad with a dull pencil, it won't matter how fast you can talk. Your job isn't done until the receiving station has the message. Remember, slow is smooth, and smooth is fast. Whatever your time, be sure that you have a realistic picture, which comes only from measurement. Without message precedence, we can see how problems emerge. Some of those alerts might be good for hours or even days, while a tornado warning might be good for only a few minutes. How do you make sure that the information that needs to get out first actually gets out first? That's what Precedence does. On a well-disciplined net with well-trained operators, a net can keep information flowing without the need for net holds or other micromanagement by net control. We'll cover 2 sets of precedents in this video. The first, commonly used in amateur procedure as memorialized by the ARRL for NTS and ARES and Radio Relay International for other message relay. The second is what we see in government circuits, described in the Allied Communications publications and implemented in Winlink. Amateur procedure specifies 4 levels of precedence: emergency, priority, welfare, and routine. Starting at the bottom level, we have routine. Without anything to escalate the precedence, a message is routine. In non-emergency or disaster operations, most things are routine. In emergency or disaster operations, routine messages are handled last, and depending on the net or the circuit, they might not be handled at all. Practice messages that we see on NTS are therefore most typically routine. Message precedence in the amateur radiogram format comes after the message number. Routine is abbreviated as R in a written preamble. One up from routine is the case of an inquiry of someone's health and welfare, or where an all okay is being sent out from the disaster area. Red Cross safe and well messages or reassurance coming out of Puerto Rico after Hurricane Maria effectively disconnected the island from the rest of the world would be examples. Welfare precedence messages use a W in the printed preamble. Welfare messages might also be more likely in the form of numbered radiograms which aid in relay time and accuracy. The inquiry type message could also use a numbered radiogram. Welfare inquiries use the precedence welfare. Numbered radiograms for inquiries will need to indicate whose welfare we're inquiring about and may need to include some additional contact information. Higher precedence than welfare is priority, which is for important messages with specific time limits, official messages, messages about an emergency, and notices of injury or death in a disaster area. Priority messages are indicated with a P in the preamble. Where inquiries about welfare or everything is okay messages are W, when indicating an injury, the message rises to the level of P or priority. Likewise, a message from an official tasked with disaster relief, sending a message to a non-government organization like the ARRL field organization official would also be priority. In amateur procedure, priority is understood to be more urgent than the lower categories of precedence, but there is no specific time delivery target. The amateur radiogram has a related feature that can help in the form of handling instructions. Handling instructions are optional for the originator, but when they are used, following them is mandatory. In this example, we can specify not only priority for precedence, but handling instructions bravo forward. Handling instructions are described in more detail in the ARRL's MPG and FSD 218 and RRI's 1720 Revision 2. I'll have links to those below. There are many handling instructions, but there's only one that we're going to cover in this example. We can see handling instructions Bravo 4 means to deliver the message in no more than 4 hours. If delivery cannot be made in that time, the message is to be canceled and a service message goes back to the originator. Our top category in amateur procedure is emergency. This is for life or death messaging being handled in the absence of normal circuits. Emergency precedence is always spelled out, unlike amateur precedence indicators of other levels. Official messages vital to emergency management or disaster relief might not always be obvious. If it's from an official, you should assume that it's possibly an emergency precedence message. The critical thing to capture is the intent of the official originating the message. It might require some understanding of the problem at hand. If working in disaster response, the radio operator will likely be part of a communications unit with a designated leader who has some understanding, or a section chief able to give good guidance on the operator's need. In our example, this looks pretty innocuous, but this kind of measurement indicates a major flood, as defined by officials, not what a casual observer would say. It also shows that the trend is rising and the pace of that change. It's important information that's needed for planners. All of that could be easily missed by a radio operator making judgment calls. The originator likely doesn't know what precedence to use. It's not their job to know the radio procedure. It's the radio operator's job to know the radio procedure and to create the message such that it conveys the official information accurately, completely, and gets it delivered in accordance with the originator's intent. In some exercises, you might hear or see a leading group in the precedence the word test. This is an option when originating an amateur format radio message. It comes up in exercises to distinguish them by precedence from non-exercise messages. If you're planning an exercise, define in your exercise plan the X plan, whether it's to be used. Don't leave it up to chance. Be explicit that exercise messages are to use it or not. Don't say that it's up to the operator. That's not good training, and it leads only to confusion and inconsistency. If you're an exercise player, follow the X-Plan instructions. While on that topic, let me add that yes, test routine is a legitimate precedence. I've used it and been chastised on air by somebody with decades more operating experience than I have. It doesn't matter. It's legit. It's used as an example in no less than the ARRL's MPG in section 1.1.2.1. When it comes down to it, the amateur message precedence is a system that helps order messages. In that, it's good. It's generally understood in amateur procedure, such as programs that ARRL oversees and those that have picked up where ARRL left off, like RRI. It does have some good definitions around things like welfare, as distinct from when to use priority for reporting on someone's well-being. It does, however, have some important drawbacks. Some definitions are vague, which encourages inconsistent use. Whether to use emergency or priority is pretty wishy-washy for a lot of cases. There aren't clear delivery time targets for these either, so the originator doesn't really know what will happen with it on the receiving end. This has been a real problem where areas officials, for example, tried to engage NTS to do something and then get radiograms in 4 days after the event is over. Also, emergency and welfare aren't understood on government circuits, which will hurt interoperability. Finally, the Winlink global radio email system doesn't recognize it, so using them for support of agencies won't work, and something labeled emergency or welfare will wind up being treated as routine, which of course is the default. That brings us to the matter of precedence in government radio services. Like with amateur procedure, government procedure specifies 4 levels of precedence. The standard for this is the Allied Communications Publication 121, which most recent revision is India. These are flash, immediate, priority, and routine. Before we show examples of each, we're going to build out a little more from the use case that we introduced earlier with the Weather Alert Project 21. We monitor the National Weather Service NWS alerts for Ohio. In that time we've been running the project, we've seen NWS issue alerts for Ohio from 5 different forecast offices and the National Severe Storm Laboratory in Norman, Oklahoma. NWS alerts are issued as Common Alerting Protocol, that is CAP messages, which have 3 elements that are of interest to us when establishing the order of messages: urgency, severity, and certainty. These elements and their possible values are defined by the CAP standard. In the CAP standard, urgency has 5 possible values when action should be taken. Immediate, meaning now. Expected, meaning within the hour. Future, meaning in the near future. Past, meaning action is no longer required. And unknown, which means the originator simply does not know. Severity also has 5 possible values in CAP version 1.2, indicating threat to life or property. These are extreme, meaning extraordinary; severe, meaning significant; moderate, meaning possible; minor, meaning minimal to no known threat; and unknown, meaning the originator does not know. Certainty is our last element and also has 5 values to reflect how certain the originator is. These are observed, meaning it has already happened or is happening. Likely means 50% or better. Possible means it could happen, but is not up to 50%. Unlikely means it's not expected, about a 0% chance. And unknown means the originator does not know. For the WAP 21, we created a set of rules based on these values to establish the precedence of the radio messages that we originate. By using the CAP urgency, severity, and certainty elements, we interpret the originator's intent. As we show here, urgency is sufficient for handling all cases except one. When urgency is immediate, severity is extreme, and certainty is observed, we upgrade what would otherwise be immediate precedence to flash. Now let's look at our example messages from WAP 21. These are all real messages in the basic message 16-line format. For the purpose of this video, they are abbreviated. The real messages were complete CAP alerts so that they could be processed by a computer on the receiving end. Let's start at the bottom, which, like in amateur procedure, is routine. ACP 121 is much more specific about the intent of handling for messages of this procedure. The target time for delivery is 3 hours after the origination or more, all the way up to the start of business on the next working day. Looking at our example message, we can see NWS Cleveland sending a flood watch. It's designated routine, as shown in the basic message format, as the initial R before the date-time group in the message preamble. The urgency on this message is future, so we don't look at severity or certainty. Another example of routine can be found where the urgency is unknown, as we see in this air quality alert issued by NWS Wilmington. The next up is priority. ACP 121 specifies that it should be delivered between 1 and 6 hours after origination. Priority messages are indicated in writing with the initial P ahead of the date-time group. As urgency is expected for this message, we again do not need to look further at severity or certainty. This is a work in progress, so this might be an area where we need to make an adjustment upon review. The next level of precedence is immediate, which means target delivery in 30 to 60 minutes. Immediate precedence is indicated by the initial O ahead of the date-time group. This has immediate urgency, which is the top value for urgency. It also has a certainty of observed, which is the top value. Severity is severe, which is not the top possible value. Thus, by our rule, the message has immediate as precedence targeted for delivery in 30 to 60 minutes. It's a severe weather statement that's good for nearly 5 hours, so that looks reasonable. But what if we need something to go faster? That's what flash means, as fast as humanly possible with the goal of under 10 minutes. On manual nets, we even interrupt other transmissions to move flash messages. Flash messages are indicated with Z for the precedence ahead of the date-time group. In this case, we are at top values for 3 elements we watch. Urgency is immediate, severity is extreme, and certainty is observed. NWS Pittsburgh issued a tornado warning, good for only 8 minutes. This simply cannot wait for something else to finish before it expires. Does this really matter, though? In the Black Swan 20 exercise, we tested the capability of radio relay of a message from the Washington, D.C. area to specific targets from the Integrated Public Alert and Warning System, IPAWS. This was the first time it was ever done, and it worked. Timeliness of the relay was variable, with some stations getting their messages in just a few minutes and others taking more than 36 hours. Some kinds of alerts can wait for hours or even days, but some are life-saving for only a few minutes and then of no interest after that. A complicated problem is how to handle situations like active thunderstorms. NWS alerts are, by their nature, very bursty, leaving most communication circuits bouncing between unused and overloaded very quickly. We saw examples of that in our model, transmitting messages in the 5-minute and then the 3-minute windows earlier. Let's take a look at some real-world examples from the Weather Alert Project 21. In one session, we had a message that was booked. That means it's one message going to more than one destination. In this case, it was an alert headed to both Erie and Lorain counties in Ohio and reckoned immediate precedence. The message came from NWS Cleveland, transmitted from KD8TTE to reps for Ohio Aries District 1, where Erie County is, and Ohio Aries District 10, where Lorain County is. Both messages made it all the way through the system of relays to the counties on time. A similar situation with 3 messages not booked led to 2 of the 3 messages making it through the whole relay on time. Kentucky Aries Districts 13 and 10 got a message each on time, but a second for Kentucky Aries District 10 did not make it on time. Another test had messages coming from 2 different NWS offices, Jackson, Kentucky and Charleston, West Virginia. In this case, we had 5 messages come out of a 10-minute period. 2 at once were immediate precedence, one for Estill County in Kentucky, and the other for Logan and Mingo counties in West Virginia. 8 minutes later, 3 more messages came out, all priority. All of these made it on time. Early in our testing, we saw several bursts and found that they were difficult to deliver on time, going from HF into the Aries district and then VHF within the district to a particular county, and then VHF from the county to a particular target. Those difficulties were not uniform, however, as training helped to make station operators more efficient in relay. The outlets in question, types of alerts, and luck all play a role. We used Winlink for much of this testing, which was made possible because Winlink supports precedence. Winlink uses government procedure, not amateur. Using precedence in Winlink requires putting a literal token in the subject line. 2 forward slashes, no space, mixed group, Whiskey, Lima, figure 2, kilo, a space, then the precedence indicator followed by another forward slash. As in any normal operation, if the precedence is unspecified, it will be treated as routine. Winlink uses precedence to establish order. Appearance of a flash message in the queue will not halt the transmission or receipt of something that's already started. During the course of this project, we were able to work with the developers of the open source Winlink client, PAT, to show how precedence works with Winlink, and they were able to implement Winlink precedence. It is now available in PAT. The Black Swan Net is designed to focus on agency needs, including interoperability on 5 MHz. We encourage the use of government precedence and the basic message format, but we will certainly handle amateur radiograms and amateur precedence. We do not recommend putting amateur precedence in basic message format radiograms, and we do not recommend putting government precedence in amateur radiograms. The systems are pretty distinct. On the Black Swan Net, however, we need to integrate things together for the purpose of net operations, so we have ordered precedence as follows. Net control on a specific occasion might have particular information and might not follow these closely. That's okay. These are a guideline for use by net control. We start with flash, and we handle that as fast as humanly possible. Next is immediate for delivery in 30 to 60 minutes. Next is emergency, which doesn't have a specified delivery target, but is highest of the amateur precedence. We then handle priority, then welfare, then routine. Radio communication isn't just about 2 people able to talk as if they're in person. These are systems that carry information for others, just like the public switch telephone system or the Internet's system of interconnected nets. Precedence helps us to make the system viable for others to use in disasters or emergencies. Amateur and government radio services both have the concept of precedence but implement it differently. There isn't any reason you can't use government precedence in amateur spectrum, but we don't recommend putting government precedence in amateur formats. No matter which spectrum you're using, keep amateur precedence on amateur formats and government precedence on government formats. That should help you to be sure that however you're moving information, its precedence will be understood by the receiver the same as it's meant by the sender. The Black Swan Net, operating in and around Ohio, supports both and is able to help us to support interoperability between amateur and U.S. government stations and to support the time targets as intended by the government station operators. And of course, this isn't just something that you pick up from a book or a video. It requires practice, so train, train, train. If you're able to make the Ohio nets, find Black Swan Net to practice. If you can't, post to the QTC mailing list at groups.io, and we'll be happy to see just how we can get you connected to our training efforts. We're happy to work with remote stations, but it does require a little bit of planning to make it work, so reach out and talk to us. We're happy to get you connected. And that's it for precedence. Have you been able to make this work on your nets? Are you mixing it up in your training? Let us know how precedence is helping your net operations by commenting below. Check the links below for references. Share this video if you found it to be helpful. That's all for now. 7-3. This is Radio KD8TTE out.